quadratic equation. So we'll be starting with nature of roots. Nature of roots. Okay. So we have a given quadratic equation, say x square plus bx plus c is equal to 0. Okay, and say a is not equal to 0. Of course, when I am saying quadratic equation, then of course a will not be equal to 0, and we okay, then its discriminant will be b square minus 4ac. So we will say if d is greater than or equal to 0, then we will be saying its root will be real. And again, I am assuming that a b c are constant or say independent of x, and are constant and real. Okay, its roots will be real. Okay, sorry. If b square minus 4ac will be equal to 0, then I will be saying its roots will be real, but will be repeated. Okay, this is one thing. And second thing is, if d is smaller than 0, then I will be saying its root will be imaginary. Okay, and again, if I am saying its root will be imaginary, then its both root will be imaginary. You must be knowing the imaginary roots exist in conjugates. Like if one root is a plus iota beta, where a and b are real constant, then another root will immediately be a plus a minus iota beta. So you must be knowing this. And yeah, let's proceed. Let's proceed with one question, which is uh, find question, find alpha if roots of x square minus 4 alpha x plus alpha plus 5 are real and distinct. So what we are given is alpha. We need to calculate value of alpha if its roots are real and distinct. So what did that mean? Real and distinct means if the roots would have been real and equal, then we would have done d is equal to 0. If the roots would have been just real, so we would have done d should be greater than or equal to 0. But here we are asked roots are real and distinct. Okay, so here we will be using d greater than 0. So d we have 16 alpha square minus 4 alpha minus 20 should be greater than 0, which implied that 4 alpha. Okay, so we will have like I can write this is a 4 alpha square minus alpha minus 5 should be greater than 0, which implied that 4 alpha square minus 5 alpha plus 4 alpha minus 5 should be greater than 0, or implies alpha common. I will take alpha as a common, then 4 alpha minus 5 plus 4 alpha minus 5 should be greater than 0, implied that alpha plus 1 into 4 alpha minus 5 should be greater than 0. So alpha will either be greater than 5 or will be smaller than minus 1. That I can say. So our solution will be minus infinity to minus 1 union 5 by 4 to infinity. So alpha belongs to this value. So this is one of the thing. And second point I want to mention, if a question is multiplied with multiplied by a non-zero constant, then its root did not change. Okay, I don't think I need to explain this. This is very obvious. And if coefficients are real, then if exist, imaginary roots will occur in conjugate pair. Okay, again I have discussed this point. Why I am okay? I'm saying if coefficient are real, then if exists imaginary roots will occur in conjugate pair. Will occur in will occur in conjugate pair. What is the meaning of conjugate pair? Again, I have discussed earlier only. A plus iota beta will be one roots where a and b are real. Then a minus iota beta will be the other root. Okay. So should I take one example or show you like that? Okay. So we have example, say x square plus 2x plus 4. So if we'll like if alpha and beta are its roots, then we will say alpha and beta will be minus b plus minus b square minus 4ac divided by 2a. Implies that minus b is our minus 2 plus minus 4 minus 16 divided by 2. So we'll have minus 2 plus minus minus 12. Okay, so this will be minus 2 plus minus 2 root 3 iota. So you can see there one root is minus 2 plus 2 root 3 iota and other is minus 2 root 3 iota. Here it will be seen to you that its roots are in conjugate pair. It's because its roots are imaginary. One of the roots, if one of the roots is imaginary, then other will be imaginary as well, and both the roots will be in conjugate pair. That is one more thing. Okay, so moving forward. Okay, what if the coefficient of quadratic equation aren't real? Then what will be its roots? Will that be in conjugate? So again, can can we say that? So again, I'm giving you answer. We cannot say that. I will just show you why we can't say that. I will just show you with an example, which is say we have one quadratic equation, 3x square minus 5 iota x plus 7 is equal to 0. So its root will be 5 iota plus minus and 25 uh, 84. Okay, 84 divided by 6. Okay, so we have 5 iota plus minus 25 minus 84. What will be it? Just a minute. Minus 25 minus 109 divided by 6. So we have one root says 5 iota plus 109 iota divided by 6. 5 iota minus 109 iota, sorry, plus, sorry, minus divided by 6. So these are two roots and it will be clearly visible that these roots are not conjugate pair, are not conjugate pair. Okay. Okay, again a question. Again I will be doing with question. So it's like true and false question. So I'm writing if roots of x square plus bx plus 5 is equal to 0 are imaginary, then they will be they will be conjugate of each other. They will be conjugate of each other. Is this true or false? Again, we haven't given the information about ab if this value are real or imaginary, so we won't be able to comment if its root will be conjugate of each other or not. Okay, so I will say false, because if it happens that a and b are again imaginary, not real number, so then its root will not necessarily be in conjugate pair. Okay, so next question is again true and false only. If one root of 3x square 3x square plus 5x plus 27 is equal to 0 is alpha plus iota beta, other root is alpha minus iota the beta. Okay, so I'm writing the question. uh, if one root of 3x square plus 5x plus 27 is equal to 0 is alpha plus iota beta, then other root is then other root is alpha minus iota beta. In this question, if we'll say the coefficient of our quadratic equation is real, but will this statement true? I will say this statement will be false. Why I'm saying this? Because we haven't given the information about if alpha and beta are real. If alpha and beta would have been real, then I can say like this exists. But say if beta would be imaginary, say something in term of iota, imaginary, of course, in term of iota, then we have been like will these two would have been conjugate pair of each other? No, not necessarily. So this statement will be false. Okay, so we will be going again with the next question, which is if coefficient of if coefficient of quadratic equation are rational number, then if exist irrational roots will exist in pair. Irrational roots will exist in pair. Will exist in pair. Okay, this is one of the thing. If coefficient of quadratic equation are rational number, then if exist irrational will exist in pair. Like if we have been given the coefficient real, then of course it both the roots will be imaginary, because like if coefficients are real, coefficient are rational number, then like we can say like the quadratic equation of type x square plus bx plus c is equal to 0, and a b c are given real, but one of the roots is sorry, let me repeat, x square plus bx plus c is equal to 0, and a b c are giv- given as rational, and one of the roots is ir- uh, irrational number. So what does that signify? that signify that root d, like we'll write root as a minus b plus minus divided by 2a. So this portion will be our imaginary, sorry, not imaginary, will be rational, and these are again rational. Okay, so one root I am saying that minus b plus root d by 2a, wait, is irrational. Then of course minus b minus root d by 2a will be irrational again. Other root will be this only. So we will say if one roots of r of the equation having coefficient rational number is irrational, then other root will automatically be irrational. So this statement is true. Okay, so that is one of the thing, and okay, I will continue in next class.